Hi and welcome to this quick little video about first principles of calculus and how to use it, and we'll go through some examples at the same time. So this is our formula here. We've got f-x, which means that this is the derivative of something, the derivative of the function x, and what we're going to do is use this formula here to find out what that is. So what we've got here is lim, which is limit, as h tends towards 0. And we've got up here f of x plus h minus f of x, all divided by h. Now, the first thing you might think of is, well, hang on a sec. As h gets smaller and smaller and smaller, wouldn't that mean that all of this just keeps getting larger and larger and larger? Well, yes and no. Once we go through and actually work out what's going on when we plug a function in up here, we'll find that this h, more often than not, will cancel out. So let's go through and see how we can put a basic function into this. So let's take the function f of x equals, let's just take x squared. I do apologise, some of my writing is going to be a little bit interesting, so let's tidy that up before we go too much further. I'm getting used to writing on this again, it's been a few years. Anyway, that's a bit better. So when we're going to put it into this function, anytime we see x, for this first part here, we're going to put x plus h. So for something like this, if we go, let's write it out, f dash x is equal to the limit as h tends towards 0 of x plus h, and we're going to square all of that because we've got this all squared, minus x squared, and we divide all of that by h. So again, we've still got this h term here, so let's go through and work out how can we simplify all of this and get rid of this h. So let's expand out this x plus h squared and see what happens. So again, f dash x equals the limit as h tends towards 0. So we expand it out, we should end up with x squared plus 2xh plus h squared minus x squared. And again, we just divide all of that by h. Now we're getting somewhere. Now we can see straight away that this x squared term, or the x squared terms, will cancel each other out. So let's go, put a line through that one, line through that one. Make that one a bit darker. There we go. Alright, so what are we left with? Well, we're left with, again, limit h tends towards 0. Every time you're doing your working out and you're showing step by step, remember to put this bit in. You'll lose marks if you don't. So, we end up with 2xh plus h squared. Let's fix that x up. Oh, got rid of the h as well. Oh well, let's fix it up. That's a bit better. Alright, divided by h. Alright, so is there a way that we could look at this bit here and take out a factor of h from this top line here? Well, there is. So we could go h, and let's write it out, f dash x equals limit as h tends towards 0 of h multiplied by 2x, fix that up before we go too much further, plus h. Now it's just h because h times h, h squared, divided by h. Now we can get rid of the h down the bottom that I was talking about before. So these ones will cancel each other out and become 1. And remember, any number divided by itself is 1. Doesn't matter how astronomically large it is or infinitesimally small it is, it will always equal 1. Alright, so let's keep moving. Now we're going to have something that looks, let's go down the line, f dash x is equal to limit h towards 0 of 2, let's write it down here, 2x plus h. So now we can go through, substitute in as h gets smaller and smaller and smaller and smaller, and just keeps getting smaller until, let's just call it as being 0. So let's go over here. It'll turn into 2x plus 0. Now I tend to put these brackets around anything when I'm substituting a number in, as it makes it stand out just that little bit. In case I've done anything wrong, I can go back, have a look through, and I'll be able to see where I might have done an incorrect substitution. So now that this limit's happened, we can actually remove that from our answer. So f dash x is simply 2x. And that's as simple as it gets for substituting into a formula. What we're going to talk about next, actually let's do one more, just as a quick, let's substitute something in. I won't solve it for you guys because it'll be just watching me do the same process again and again and again. So let's pick a function that might look a little bit like f of x is equal to 3x squared. Well, let's just keep it as 3x squared. So we've got a number out the front this time, so it will change it a little bit, but as we substitute into this formula again, the formula that's up the top, so f dash x is equal to, again, limit as h tends towards 0. We're going to have 3 out the front. So remember, it's only just whenever we have x that we're going to substitute x plus h in. X plus h, all squared, minus 3x squared. And we'll divide that again by h. Now, what I want you guys to do is have a go at solving this one yourselves. See what it comes out like. Hopefully you'll get something that will look, it should turn out to be equal to 6x. Now we'll go through, there's a really simple way to go from that to that, but we still need to go through this process here. So have a go at it, see if you get this same answer. If you don't, have a talk to me in class and I'll go through and see what's happened. And good luck, guys.